Hello. In this video, I will do example 7 of related rate word problem. Okay, so can you see this? So example 7 says about, hold on. Let me see if you, yes, you can see it. Okay, I was just making sure I was in full screen. Okay, now I am. So example 7 says a boat is pulled in by means of a winch on a dock that is 12 feet above the deck of the boat. The winch pulls in the rope at a rate of 4 feet per second. Determine the speed of the boat when there is 13 feet of rope out. Okay, so I'm going to draw an image. So here we have a dock. Right here is like a dock, and then here is the ocean or the water. Okay, and then here is the boat. So let me label this as the dock, and here's the boat. Okay, so the boat is slowly going to the dock, and uh, so a winch is pulling the boat into the dock. So here, let me show you what they mean. Here's the winch. And it's slowly pulling the boat into the dock. So somehow it forms a triangle like this, right? And then they're saying that they're saying that it's 12 feet above the deck of the boat. So this length here is 12 feet. And what else? Okay, let's read the problem again. So a boat is pulled into uh, by a winch on a dock that's 12 feet above the deck of the boat. The winch pulls the rope at a rate. So rate is a speed of 4 feet per second. Determine the speed of the boat when there is 13 feet of rope out. So they tell us the speed of the winch. So we'll call that dr/dt. Now, as you're pulling it in, the speed is slowly getting smaller because eventually it's going to stop. So it's going to be negative 4 feet per second. Okay, so what we have to find is dB dt. We're trying to find the speed of the boat. So dB on the top, and we always take it in respect to time. Okay, so how do we find the speed? Well, we kind of have an image. We have a right triangle, right? This right here forms a right triangle. So maybe we can draw that again. So this length here, this forms a right triangle. We know that this length is 12 feet, and we call this the rope. And what else should we call yeah, so this is like the winch, and that's like the rope that's pulling the boat in. And then I don't let's use call this B, because we're gonna use Pythagorean theorem, right? So we're not looking for a missing angle. I think what we're doing is we're gonna have to find missing side lengths. Since it is a right triangle, we can use Pythagorean theorem. Um, A is a leg, B is a leg, C is a hypotenuse. Well, okay, wait, hold on. How much variables do we have? Oh, we can replace A with a leg, so that would be 12 squared. So now we have two variables. That means we should have one rate. So that makes sense. We do have one rate, so we don't have to substitute anything in. So let's just take the derivative implicitly. So let's start with 12 squared. The derivative of a constant is always 0. Plus the derivative of b squared in respect to time would be 2b, and then you have to add the db dt because we're taking it in respect to time, right? And then let's call, instead of calling this c, we call that r. Yeah, minus 3. So r squared. So what is the derivative of, so the r stands for the rope. What is the derivative of r squared? It's 2r and then dr dt. Okay, and then our goal is to solve for db dt. But we kind of have, wait, so we kind of have a problem, right? Wait, let's just get rid of this 2. Let's easily get rid of, to make our life easier, let's get rid of these 2 by dividing both sides by 2. So the 2's cancel, so you're left with b db dt equals, and then this 2 cancels, so you're left with r dr dt, right? Okay, now what? Our goal is to solve for db dt. That means we got to find the r and the b. We have dr dt, right? So I'm gonna have to wait. Let's get rid of this b by dividing both sides by b. So db dt is r dr dt over b. Now we know what dr dt. Do we know what r is? Yes, I think that was given. They're saying that when there are 13 feet of rope out. So yeah, so this would be, you can replace this with 13 feet. Wait, so let me write that out. So 13 feet times dr dt. Dr dt is, we said was -4 feet per second because we're pulling it in, so eventually it's going to stop. So that's why it's negative. So it's going to be -4 feet per second. And then all over b. So how do we find our b? Well, they tell us that r is 13. So we can draw another triangle, right? We can draw another right triangle. So we said this was 12. And then they said that when the speed when there's 13 feet of rope out, so this length here is 13. And then we don't know what b is. So now we can find b by applying Pythagorean theorem. So 12 squared plus b squared equals 13 squared. 12 squared is 144 plus b squared. And then 13 squared is 169. Solve for b, so I'm going to subtract 144. B squared is 169 minus 144 is 5. Take the square root of both sides, you get b equals to 5. I'm not going to use the negative because it wouldn't make sense to have a negative b value, right? Okay, so you could say db dt is, let's simplify, what's 13 times -4? -52 feet per second. or I guess it would be feet cubed, right? Because this was 15. I mean, this was feet, this is feet, so this is not feet cubed, feet squared per second divided by b, which we said b is 5 feet. So negative 52 divided by 5 is, I don't think it can be reduced. I don't want it as a decimal. So it would be dB dt equals negative 52 feet per second. So I think what happens is the feet cancels kind of. So we have a complex fraction. So let's see, we have feet square per second divided by feet. This would be feet. If I cross multiply, that would be feet square. And then this would be second times feet. And then as you can see, this cancels this one. So you're left with feet over second. Okay, so I think, okay, so you're probably thinking, why is my rate negative? You could think of it as the rope is getting pulled into the length. As the rope is getting pulled into the dock, and the length of the rope is getting smaller, and thus the speed slows down. So let me write this down. As the rope getting pulled in, the length the rope getting smaller, and thus the speed slows down. Okay, so that is why our rate is negative. So that is our answer for this one. Okay, I will stop here.